Hi guys and welcome back to Aisha.Academy, and in today's video we're going to be going through basic differentiation, so just the basics of differentiation. Okay, so this is the first video of the differentiation series that I will be recording. So first of all, the derivative, or also known as the gradient of y, we always write it as dy by dx. Please be familiar with this format, okay? So we call this the derivative or your gradient. Now, you may be asked in exam questions to differentiate from first principles, and a lot of times this confuses people because they don't know what the hell this means. So for instance, if an exam question says, prove from the first principles that the derivative of 4 times x cubed is equal to 12x squared, this is the formula you want to be using anytime it mentions first principles. And luckily, this formula is given in the exam formula booklets for all of the exam boards. So luckily, you do not have to memorize this formula. But basically, this formula is that if you have f of x, remember that f of x is interchangeable with y. If that's equal to lim, and then underneath you have a h and then the arrow o, that's just the formula. You basically have this lim, and then you have f bracket x plus h, close your bracket, minus f of x over h. So this is the formula. Now, how to apply our 4x cubed to this formula? What you now do is your lim h arrow o is not going to change, but the 4, the number in front of x, is going to replace your f. And then the cubed part is going to go outside of the first set of brackets. So it goes outside of the bracket with the x plus the h. This is really important to remember. And then again, your 4 is substituting your f, so it's going to be 4x cubed. Okay, so the f of x is 4x cubed, so that's why that's that. And remember, this is all divided by h. Then the next thing you're going to do after you've written it out in this format is just simply you're expanding and you're going to simplify. So the 4 bracket x plus h cubed, we are going to expand those brackets, and that is going to leave us with 4 bracket x cubed plus 3x squared h plus 3x h squared plus h cubed, close your bracket, and again your minus 4x cubed is not going to change. And remember, this is all over h. And then next now we are going to simplify, so expanding the brackets, simplifying. So simplifying this would leave us with 4x cubed, because we're expanding the first bracket, plus 12x squared h plus 12x h squared plus 4h cubed minus 4x cubed over h, because remember this is all over h. And then essentially simplifying this now. So imagine you simplify everything on the numerator, divide everything by h. This should leave you with 12x squared plus 12xh plus 4h squared. So as h is, and then the arrow to 0, do not put equal to 0 in an exam question. They are not interchangeable, but essentially they are when you're substituting. We're going to substitute h is equal to 0 into the simplified version that we had. So you're going to substitute the h for 0. And then once you've substituted h for 0, you're then going to work out what your answer will be. And if you now notice, this is going to leave you with the 12x squared, which is what they want you to prove. And that's all you need to do. Now, after when it comes to first principles, we're actually going to go into differentiating powers of x, aka your usual differentiation that you may be familiar with from school. So if we have f of x, so remember how f of x, function of x, is this really interchangeable with y. So f of x or y is equal to x to the power of something called n that I've put it as. If we were to differentiate this, when you're differentiating your function x, remember you put f dash and then the brackets of the x. So the dash may not be clear, but I've just mentioned it. So always put f dash. Or again, because y is interchangeable, it's the same as saying dy by dx. This would be equal to n times x to the power of n minus 1. So your initial power comes to the front and then you take 1 off the power. So that's how you differentiate. Another rule of differentiation that you should be familiar with is, again, if we have our f of x, also known as our y, and let's say this time is equal to a times x to the power of n. If we were to work out the derivative of this, also known as the gradient, as mentioned earlier, again, you would still have your f dash x, because remember that's how we write the derivative for functions, or also known as your dy by dx. Again, as I mentioned before, you bring the power to the front, right? So you're going to bring the power to the front, so it's going to be a times n times x to the power of n minus 1. So you still take 1 of the power and bring the power in front, but this time we're multiplying it by whatever was already in the front. So I'm going to give an example of some questions of these. So for instance, if a question was to say you have y is equal to x to the power of 6 and they wanted you to work out the derivative, you would write out your dy by dx is equal to, we'll bring in the power in the front, so it's 6x to the power of 6 minus 1, because remember we take 1 off the power, and so this would simplify to 6x to the power of 5. Another example, if we have y is equal to 3x squared and we were to work out the derivative, you would write out dy by dx. Again, you bring the power down, so multiply it by whatever's in the front. So it'll be 2 times 3x to the power of 2 minus 1. This would now simplify to 6x, because remember, anything to the power of 1, you don't actually write down to the power of 1. So this works the same for fractional and negative powers. They are differentiated in the same way. So I'm going to give an example of a negative power being differentiated first. So for instance, if a question says y is equal to the x to the power of minus 3, and we were to work out the derivative, you again write your dy by dx. Same rule applies. So you're going to bring that power to the front, so you're going to end up having minus 3x to the power of minus 3 minus 1. You still take 1 off the power. And so this would now simplify to minus 3 to the minus 3x to the power of minus 4. So notice how it's still the same rule. Again, I'm going to give an example with a fractional power. So let's say if a question says you've got y is equal to the square root of x. Remember, the square root, if we now change it into a fractional power, is the same as saying x to the power of a half. So again, you would then write your dy by dx. Same rule is applying, remember, so you're going to bring that power of a half to the front, so you're going to end up having a half x to the power of a half minus 1. And now if we were to simplify this, we would end up with a final answer of a half x to the power of minus a half. So last but not least, I want you to be aware of special cases when it comes to differentiation, just to save yourself time in an exam as well. So the first one is if you have y is equal to a to the power of x, a just being any number, and we were to work out the dy by dx of that, it is going to be equal to a. Because if you think about it, if you take 1 off the power of 1, you end up with 0, and anything to the power of 0 is 1. So that's why that's that. The second special case, if you have y is equal to a being a number, So this time x is not next to it. If you were to work out the derivative, dy by dx, it would be equal to 0. And so that comes to the end of the first video in terms of basic differentiation. Stay tuned for the rest of the videos to come of further differentiation to do with tangents, normals, differentiation of trig, and so on. Thanks for watching, guys. Like, comment, and subscribe, and thanks for watching again.